Okay, welcome to Tech Tuesday number 67. Today we'll talk about a concept I call juicing dry. The idea being that if the inventor has disclosure, you want to get every last bit out of the inventor. And, sometimes you have a disclosure. So you say, okay, let's draft, or maybe not draft, but let's figure out what to protect or what to claim. And I'm saying, wait a minute. Just because you have a disclosure, maybe it's not actually complete. Maybe it doesn't include all of the details you'd like to have. Now, I've spoken about details in patent applications before, but what I want to talk about today is the act and the problem with extracting details from inventors. And I'm talking about details. I'm not talking about inventions. I'm not talking about invention mining. And I'm definitely not talking about exploring the invention where you work with the client to figure out maybe what he did actually invent. This is just about getting all of the details you need in order to do these things. Now, I said we have a disclosure, but actually, let's ask, did the client provide a disclosure? If he did, is the client complete? Is the disclosure complete? Or maybe it's a disclosure that the client told you by phone and you wrote it down. So in all of these cases, even when the client inventor supposedly provides a complete disclosure, you still have missing details. But I hope it's clear that the approach that you use in order to get the missing details from the inventor client are going to be different. Now, I note that I didn't talk much about the client. I'm talking mainly about the inventor. When you have a client, an IP manager, so that client is between you and the inventor. So maybe that IP manager should be doing everything that I'm talking about here. Question you might ask, how do I know that if you got a complete disclosure, that there's stuff missing from it? Well, first of all, my experience is there's always stuff missing. More than that, there probably should be some stuff missing, secrets. But I just do basic math. Most inventions, the inventor has spent hours, days, or months working on. So the inventor knows much more than she gives you. And usually it's less than we want, but that's not part of the discussion today. Somebody commented on LinkedIn that you can use intuition or experience to know that your disclosure is incomplete. And sometimes it's a cultural issue. You see what culture the inventor comes from and you know what's missing. And sometimes it's a pattern of disclosures they give you, which you've already seen 5, 6, 7, 20 times, and you know it has holes in it. Now, I want to be clear that just because we're missing details and we want to get these details, doesn't mean that all of these details will actually go into this patent application. They might go into the next patent application. They might be used in order to help us decide what should be secret and what should not be secret. And maybe they'll just be used to help us understand what it is we want to protect and how we'll protect it. Now, obviously, this is a question of experience, but I think if I give the pointers I'll give today, it will help all of us who take disclosures become better at it. And I'll also suggest a few tools that might be helpful. So I guess one of the questions we have to ask is why are details missing? And it's one of those, both sides are at fault, both the patent attorney and the inventor. And I want to make it clear that even if everybody was perfect, information is not only missing, it's also inconsistent. And one of the reasons is that usually you draft a patent application, hopefully you draft a patent application before the invention is actually complete, and the product is fully designed. So by nature, it's going to be incomplete in some way. Now, some things you just don't know, the inventor, or or at the level of know-how, or is there some other type of intuition that it's difficult to put into words? Some things are missing because the inventor doesn't tell us. Why not? Maybe the inventor thinks it's a patent attorney knows what a thingamajig is, or should know what it means. And in fact, sometimes the patent attorney does know what the inventor thinks that they know, but the patent attorney doesn't understand it or doesn't understand the relevance. In general, context is often missing. The inventor has tons of context. The client has even more. The patent attorney less. There's an issue of time and attention limits, both in preparing the disclosure and in taking the disclosure. I'll talk about it a bit more later. What is considered to be true or certain and what has value, I find that inventors look at it very differently from patent attorneys. And that affects, of course, what they say and what we want to hear. Sadly, a lot of inventors are either lazy, I could have said they're scared of writing, or they don't want to think about the invention, but let's just call it laziness, or they have fear, patents are scary, so they want to be done with it quickly, or they're ignorant of what actually has value. So they're ignorant about patents, they're ignorant about what you can do with IP or what you need in order to get good IP, or they might be ignorant about the particular patent attorneys they're working with. They think he knows something, he doesn't know something. In addition, there are all sorts of things that the inventor might believe are irrelevant, not important, secret, not inventive, simply forgotten. I did mention the inventor was working for months on the invention. It doesn't work well, a failure, something they don't like, something that's not in the main line of the R&D or in the main line of the business. All of these are reasons why things are not provided. And a very important reason on the side of the patent attorney is what I call stop dig signals. The patent attorney gets some sort of signal telling them, you don't need to know more about that. Patent attorney tells themselves, okay, I understand everything I need to understand. If I try to ask, people will get upset, I'm just not going to ask. There's all sorts of different signals. And one of the things we have to learn as patent attorneys is to identify these signals and understand the consequences. I'm not saying to dig when we shouldn't. Here's a few things that are often missing in disclosures that I see. And of course, it's very dependent on the technological field. And even if what you get as a disclosure is a scientific paper, then definitely you're going to have lots of missing things. Most inventors had previous designs and failures along the way, or ideas of what might work. They know it, but they're not telling you. Or they might have a next version or a production version, somewhere down the line. And we're writing a patent now, so we don't have to talk about it. I've had a case when an inventor said, oh, of course, we're not doing what I just told you. We're planning on doing something else, but we haven't finished developing, so I'm not going to talk to you about it. Another thing which is often missing is the reasons for providing one feature or another feature. Another type of thing that is often missing is why what's the inventor doing might work. There could be more than one explanation, and you might not know which one is true, and why it might fail. Definitely, they don't talk about that. Pesky things like settings, parameters, dimensions, material, what software libraries, how do you do calibration, how do you do setup? They're boring. They often don't make it into the disclosure, even though the protection could be wonderful. How things interact, external things that are not part of the invention, processes, devices, other people, no. The whole side of the user interface or user experience, depending again on the invention, the best protection might be from the interaction with the end user, But the inventor is developing the thingamabob that makes it work 5 times as fast. So they don't tell you about the person using it and how working 5 times as fast is important. Any part which appears to the inventor to be similar to existing components or to what the competition is doing, often you're not going to hear about it. Business issues, competitor information, you're often not going to get. All of these things I'm talking about are things that I would like to know, and they would affect the quality of the PAN application I would write. So, for example, business issues and competitor information, the inventor might not have. So if you have a client, the inventor invented a technology, and they might not even be aware why it's important for the business. Prior art in general, and especially what I call inspiring prior art, some inventors don't want to admit how they got to the invention, and in particular, that they saw a piece of prior art and decided to change it. Things they haven't done yet in general, problems they haven't solved yet, or they think they haven't solved yet, but if you get enough information, maybe they solved it enough for the patent attorney. And, enough examples in general. We like having examples for all sorts of ideas, and usually we don't get some. So juicing dry is about getting all of the information out of the inventor. And here are a few tools that you might use. And in the next few slides, I'm going to give a few more details about some of these tools. But the most important one is when you get a disclosure, or if you're listening, same thing, very carefully reading and rereading and identifying where your understanding is imperfect. And I emphasize anything you don't understand, there could be something big hiding behind it. So don't smooth it. Aligning the language and the jargon that you understand and that the inventor understand, different words or the same word might not mean the same thing. Another tool is using the inventor as a sounding board. You repeat to the inventor what you understand again and again, and make sure that the inventor agrees that you actually understand. If you structure the disclosure in certain ways, for example, around the invention or around the product, that helps identify all of the details you might want. Coherence has to do with making sure that everything fits together. Actually deciding that you're going to dig in for details in a certain place. Looking for hints, looking for a twist, talk about that, looking for reasons, figuring out who is benefiting from the invention. These, of course, translate into questions. Identifying what assumptions you or the inventor are making about values, principles, constraints. You could have standard questions that you ask. I have not put them in this presentation. There are metaphors that you can use, and I'll talk about one, and there's a tool using hats, which I will talk about. Why do I like using the juicing metaphor? First of all, we often tend to imagine the inventor as a lemon, and we squeeze the inventor until she gives up the invention. And in fact, it's a good metaphor because the inventors are often stressed out by the process. And something else we can learn is that juice is only part of what you can get out of a lemon. And the other things can also be used. And another important point, the lemon has a structure, but when you juice it, you destroy the structure. So maybe you understand the invention, but you lost the context. And your patent application sometimes need to reconstruct the entire structure that was hiding behind it. And just like with juicing lemon, sometimes you should look at the whole tree. Sometimes you should choose the right lemon to juice, the one that's ripe. That goes into invention mining. And you should be matching the juicer to all of the different properties of the fruit. Usually we just say whoever's there do the job, but it might not be the right way. Different inventors different technological stages of the invention, different reasons for writing the invention. Should probably have somebody else taking the disclosure. I decided to give you an example. Okay, here's a pair of scissors. I have one exactly like this at home. Took a picture. And you can see it has two sharp metal blades, the pointy at the end. They rotate relative to each other on a pivot pin. And when they rotate, the edges of the blades slide by each other. And you can see this cool orange plastic finger hold. And in case you say you still don't know how it works, I have a movie. Okay, I'm sure you've all seen that being done in the past. Okay. And basically, how do you use the scissors? You open the blades, you put a piece of paper between the blades, and you close the blades, and then you do it again. Or there's another way of using scissors. You can fold the paper in half and take just one of the blades of the scissors and cut. And if you watch movies or television, you know there's other things you can do with scissors. Before we continue, does it look like we have all the information we need to draft? A lot of people would say yes. So maybe you don't know the exact dimensions, or you did see my hand, but you don't know the ranges. You don't know the preferred materials, but we might not actually have them. But let's just say stainless steel and nylon. But no, this is not a good disclosure, not a complete disclosure, even though we've often seen disclosures just like it. In the patent attorney's exam, for example, this is often a little bit more than this, the level of detail of disclosure that is given. So here's some questions that I would want to ask after looking at the disclosure. And these questions, most of them, the client, the inventor actually know the answers. But if we don't ask, we won't know. Do the blades have to be sharp? Do they have to be parallel? Is there a screw? Why is there a screw there? That's a very interesting shape of the handle. What's so special about this shape? We have a sharp tip, but it's a bit rounded. Why? We don't see the overlap between the metal and the handle. How far in does the metal go into the handle? What is the mechanism that makes it cut paper? Can you use it to cut wood? And this looks like a very sophisticated design. What prior designs did you try making and you decided not to use them? Now, I just want to be clear, none of these questions have to be answered if what you want to do is to produce a good-looking draft. Okay, from what you saw in the previous movie, you can definitely write a set of 20 claims and draft a disclosure with a few figures describing the invention. It's enabled, it's complete, it covers what appears to be the invention, but maybe you won't do a good job. I believe that in order to be a good patent attorney, it depends on your personality. I think a lot of people agree with that. They might not agree with what I think is important in a patent attorney. That's fine. But everybody probably agrees that a patent attorney needs to have attention to detail. For example, when they write, they should be able to write consistently. I think that in extracting details from a client, there's three different personality traits which interact and which I personally believe are important. One is being persnickety, which means you care about every little detail. One is insatiable curiosity. And one is scrutinizing. Just because you have it doesn't mean you look over it again and think if it's really correct. So if you have an inconsistency, obviously you need more details to settle it. If you ask why, the answer is usually going to include details. And any details you get, you have to look at them in a slightly skeptical eye, and that usually leads to more. If you're familiar with the 5 whys method call it quality assurance, fault analysis. It's similar, except we're applying it to all information, not just the failures. Let's talk a little bit more about these tools that I showed. Coherence. It really helps you identify missing or unclear things. Sometimes the coherence problem is in our mind. But guess what? If the patent attorney doesn't have coherence, it's not going to be a good patent application. The text often contains apparent contradictions until you find out that a metal connector and connector made of metal are not exactly the same thing. Okay, but first you have to notice that the client used two different terms. And then the client, you can ask the client, and he will explain that one is a connector that connects metal, which is usually made out of metal itself, but maybe made out of plastic, versus connector made out of metal, which could be used to connect plastic or wood. The process of describing or describing again, especially back to the inventor, can be helpful. And any contradiction between what the inventor says we want to get and what you understand the disclosure will provide is worth talking about. There's something called a ritual. A lot of what we do is standard engineering practice, basically a ritual. We do it because the previous engineer did it. Rituals, by their nature, often are not coherent with the rest of the disclosure. But you have to assume that nothing is a ritual and everything matters unless the client tells you. And if they do, we're going to get to the twist later. I tell the clients to apply exactly the same standard to me. In other words, if you see any inconsistency, any lack of clarity, any tiny mistake, who knows what's hiding there? Okay? Coherence goes in both directions. The twist. When you build any product or even a proof of concept, you have to make a lot of decisions. Some of them are conscious. You think about it, put a screw, put a nail, add some glue. But even the conscious ones, the decision you make is often based on a habit or rule of thumb. And most of the product you make is old. It's unusual to have a product that everything is new about it. And the way the product interacts with the ecosystem is also usually old. Now, here's the point. When you put old and new in juxtaposition, they usually don't work perfectly together, or they could work better. So you might make a change in the new in order to work better with the old, but you might make a slight change in the old in order to make it work better with the new. I call that the twist. And let me give you an example. There's something called power over Ethernet, where your Ethernet cable also provides power to the Ethernet device. It's common, for example, in Wi-Fi range extenders. And the plug is RJ45 compatible. So that is not going to change. But in order to work better with power, there's changes. Sometimes you use more of the wires than you usually use in Ethernet. Sometimes you have extra power circuits or protection circuits in the network on the end device. And if you think it doesn't relate to you, I'm sure some of you have used a USB cable that fit, but it didn't charge very well, or the data didn't go through very well. That's because people put new uses to standard, and when they sell you the cable, it's more robust, less noise, and so on, but you don't know about that. So when we write a patent application, we do want to know, what are you going to change in what's old? What twist are you going to put in so that it interacts better with what's new? A lot of things are clearly not the invention. Things that don't work. things that were done before. Just these reasons are not enough not to write about it. In fact, if the inventor is capable of showing you multiple examples, some of which are not so good, it has a little bit of value in confusing the competition, but it has a lot of value in helping you generalize and abstract what the invention is and shows a patent office that you know what it is. We talked before about version 2.0, that it wasn't invented yet. Well, maybe it will never be invented. There's often an ecosystem. Maybe it doesn't exist yet, and the inventor is definitely not planning on building it. But at the very least, the interface between what you're doing with the ecosystem, that can give you very valuable protection. And we should always remember, patents can reach past the products that you're selling. I always use the example of the App Store, that Apple's patents can be used to sue, not patents, but the licensing model of the App Store can be used to collect money from clients of app providers, even though these clients might not be getting any special services from Apple. So just because something is not the invention doesn't mean you shouldn't describe it, and definitely means you should get the information from the client. You've got to listen very carefully to the inventor. Now, I've said before that the inventor has a particular solution they believe in, and they're not going to, perhaps not going to tell you about anything else. But even when they do that, you often hear some hint about the past or problems or relationships. And here's a few examples. The inventor says, and it comes out cheaper. Oh, price was a problem. Or marketing says, or we had X, but now we have Y. Or you see that he added a new hole in between the versions. Or we made this change. Okay, why did you make that change? Oh yeah, because our competitor does it. Well, is it freedom to operate problem? Opposite? I don't know. So, and last but not least, if they give you a shopping list, you can make it out of any of these materials. Does that mean they thought about any of the materials or that they didn't think about the materials? If they thought about the materials, that's very valuable information. If they didn't think about the materials, well, it's good to know if any of the materials is actually better. They probably know, they probably didn't tell you. There's the issue of journey, and there's two kinds of journeys that I'm going to talk about. One is the customer journey, and one is the IP journey. A common way of writing patent applications, which I alluded to regarding the scissors, is that you start with the claims, you get a disclosure, you draft the claims, you make sure that you have all of the details you need to support the claims. And if the inventor said anything else, you put it in as well, because the inventor said it, you don't want to leave it out. And without going into more detail, you have all the details you need. But you could have an IP journey. You get details. You identify inventions. You understand better. Now that you understand better, you understand which details you're missing. So you ask for them. And this can go on a few times. So that's the IP journey. And if you do it right or wrong, depending on how you believe patents should be written, these details can lead you on this journey. There's also the non-IP journey. So user experience and customer experience, like talking about the customer journey. And the idea in customer journey is that you describe what the customer is doing from the moment they decide to use your product until I don't know when. And the idea is to identify all of the customer touch points. And if there's an invention or product, it could interact with any one of these touch points, even though the customer is not actually interacting with the invention at that time. For example, the decision of a customer to buy might depend on the compression method you're using, even though at that point he's not using your compression method. So if you're able to have a customer journey you should expand it to understand all of the interactions between the customer and the product, and also with the rest of the ecosystem. And details here help you understand what could be protected and what could be valuable. From a legal perspective, the requirement is to describe something that works with sufficient enablement and so on. And in some countries, you have to describe a technical problem, or it could be implicit. But what you don't have to describe is a reason for doing any of it. On the other hand, if you understand the reason why a detail is there or not, it helps drive, like I said before, your ability to do generalization and abstraction. It helps the patent attorney understand what's going on, and it helps you check for coherence, because if something is done for one reason, and then there's a detail which contradicts that, you have a coherence problem. The concept of benefits. What benefit do we get by doing something? I hope you know about ripples, which basically say you have the invention, but like a rock that's thrown into a pond, it has effect further away. If you understand the benefits, you understand better what ripples might exist and why they're interesting, and it enables you to protect these ripples. At the same time, when you think about obviousness rejections or one-on-one rejections, if you're able to talk about benefits, then you have a better position with the examiner. Problems. If you know what the problems, plural, that your inventor is trying to solve, you probably understand better why competitors might copy, and then which parts they might copy. And in fact, usually it's not just one problem, there's a whole tree of problems, and gives you structure, helps the patent attorney. I like talking about external problems, which everybody has, and internal problems, which are raised by the particular design choices you're making. And obviously, each one is a different set of details and different way of improving the patent. And we have a little bonus here. Inventors are usually happy to talk about how they solved the problem. I mentioned assumptions. Both sides make assumptions they shouldn't be making. And sometimes the assumption is ignoring what the examiner thinks. What is connecting? What is surrounding? Patent attorney assumes it, the inventor assumes it, not so good. Sometimes you have assumptions about the invention itself, what's good, what's important, or you have constraints which are very close to assumptions. The company can only do A or can only do B. The assumptions can be unwarranted, which means that if you don't identify them, you're going to be missing a lot in your patent application. Or they could be absolutely warranted, these assumptions, but then it helps you understand the shape of the solution space. And even though we're not talking about exploration, if you understand the shape of the solution space, it helps drive the exploration, which you should be doing. Exploration of the invention. How do we know that we're done? Okay, you listen to me here, we could be taking details all week. So yeah, usually the reason you stop with a disclosure is because you run out of time, you run out of inventor, you run out of money. So you should be thinking about the order that you collect the details, and you should do triage. Obviously, the most important is to have description and enablement for the entire scope of the claims. That's obviously the most important. And it's desirable to have details that shows the grasp of your invention, support fallback, and support changes, because they will happen. But you also want details for other reasons, like what I call tactical goals, to prevent you being designed around, or for strategic goals. For example, if you want to license a patent. And the word enough basically means what kind of risk am I willing to take? And you need to leave time and energy to other processes like exploring or uh, patent mining. It's usually the same people involved, and you have a time limit. And two related issues that I'm not really going to talk about. One is how much should be stuffed into the application, and I already alluded to before, not everything. And a related question, how do we know that we have enough details to write a first draft? And my answer here is that if you can predict that new details, when provided, will not change or force a change in the structure of your patent application or in your understanding, then you have enough details for the first draft. How do we do it? It definitely sounded complicated and detailed, and I'm suggesting a hat method. And if you're familiar with Edward de Bono's six thinking hats, he says he has six different ways of thinking, and you should apply them at different times. So, six different characters you should be playing when you're taking a disclosure. The first one is an inventor. If you was an inventor, you need empathy for this. How would you see the invention? What would you forget to tell the patent attorney about? Interrogator, that's easy. What details do I want to get and what's the best way to ask? Filter, that's helping you do triage so you don't waste everybody's time. User, okay, it's not the inventor, it's not the patent attorney, but somebody who's using the product. What interests them? And you need to have also a strategist who puts the details together in order to build some sort of cognitive structure of what the invention is and helps find coherency problems, missing assumptions, and so on. And I'm suggesting that you should play act these parts when you're talking to an inventor and trying to get out of disclosure. Mentioned before that inventors do not always enjoy the process of disclosure. Some of them are asked to write a document and they don't want to write. Some of them are willing to talk, even for an hour, instead of writing, but some of them don't even like talking. And if they do write, they want to give something that's aligned with their goals. They already wrote a technical document explaining the product. They just want to chop off a few parts and give it to you. So they're not going to talk to you about, perhaps, what your competitors might want to copy or what's particularly inventive. And don't forget that in a lot of places, especially in companies, the inventors, even if they get a budget of time to talk to the patent attorney, they still have deadlines which they have to meet for their team. And talking to you comes instead of meeting the deadline. Talking to a patent attorney who seems like they don't understand is painful. We can try making it fun, the whole process, but really what you really want to do is make it short. And I'm not promising any method which is guaranteed to work for anybody. Disclosure is easy compared to getting them to read the draft. Reading it once, well done. Getting them to read it twice, you're a genius. Most inventors will not agree to do that. And a good patent needs input, details from the business people. Well, the business people hired the technical people so they won't have to deal with patents. But you still need it. The patent attorney has problems too. Does the patent attorney have an ego? Absolutely. Sometimes smaller than this building, sometimes not. They want to look knowledgeable, okay? If you're an expert in physics and you're meeting a physicist, you want to look like you understand. You also have a PhD in physics. Sometimes the patent attorney fears, perhaps correctly, that getting too many details will slow down the drafting process, or asking too many stupid questions will make the inventor say, no, I want somebody who understands me or pretends to understand me. Also, the more questions you ask, the more disclosure fatigue you get. So that's one type of problem. Another one is the patent attorney might actually believe that they understand the invention, or even just agree with the inventor when the inventor says that the patent attorney understands the invention. It's happened to me more than once. The inventor said, yes, Mayor, you got it. But deep inside, I know that I didn't get it. So I ask again. It takes time to cultivate that. What should we do about all of this? Well, Feynman told us not to fool ourselves. I talked before about triage, making it fun, have a logical structure of the questions you're asking and an understanding of what the invention is. Sometimes you ask for the details after you wrote a draft. It's easier for people to go over a draft and give details than to answer. Sometimes you provide details and ask the inventor to confirm them. AI can do it. But of course, some inventors object to the presence of details, especially the ones they didn't want to give you, like a range of numbers that might work. This is especially a problem for inventors who only give you data that's been proven to work. IP Manager, of course, is super helpful here. Educating the inventor with what is important and why, and stories of what worked and what didn't work can also help getting this process flowing. And like I said before, I don't have any solution. It's not that here's 4 tools, use them, you're going to win. When you're done juicing, you have leftovers. What do you do with the leftovers? So before you say, let's throw them away, just remember that grappa is made from the leftovers of juicing. So you can get some good stuff from the leftovers. Generally, some of what the inventor has should go into the patent application. Some of it should just help you understand. Some of it tells you about, informs you about things like freedom to operate or competitors or maybe trade secrets. In any case, there are leftovers and give them attention. Now I have 3 different cases of details. The first one is a mechanical invention. So mechanics is easy in this sense because when you actually build a machine, reality hits you in the face immediately. So mechanical drawings, real mechanical drawings, not, napkin drawings, have a lot of details in them. And if you're lucky enough to have an actual device, you can see hints of how it was put together, which is problems, or where it's worn out. Some of these details are just useful to make sure the patent attorney understands what's going on, but some of them are directly to the invention. You ask the inventor, why do you have this little piece missing here? Oh, I took this piece off to compensate for an extra piece I put somewhere else. If you look at a series of devices that the client went through, you can see features appearing and changing and disappearing. And the more details you have, the more likely you are to actually understand what's hiding behind the invention, up to a limit. Here's another example, experimental results. They did an experiment, Viagra, the great experiment. It doesn't work well. That's the output. No, it's not. They have a lot more information that they're not telling you. Usually when somebody does an experiment, the inventor is looking for proof, which means outliers are ignored. And if you're talking about FDA, you don't want them to happen. And if it's not statistically reliable, it can't go into your scientific paper. Any contradictions are bad. So there's a intentional blindness. What inventors do not understand, that the standard for plausibility is much lower for patents than for scientific papers or for FDA. So there's a lot of outcomes, like with Viagra, that if somebody takes the trouble to ask, can become very valuable IP. In addition, there's a lot of know-how generated simply by the people interacting with the technology, with the patients, with the wet stuff that you mix together. And you have to extract it, and maybe you're protecting it with patents, and maybe not, but you need to extract it. So I have two stories. One is Viagra. Viagra wouldn't exist if the nurse wouldn't have been observant enough to detect the side effect of taking the pill. Different drug, latisim, helps eyebrows grow longer, but it was only recognized after the drug came to market. It definitely could have been recognized earlier, but presumably people were not looking at it. And I took a little bit of looking at the IP, and the IP that they got is not as good as it could have been because the idea was known before. Only the details they got protection on. Yeah, we know details are good for fallback. And here's another possibility. You don't have any disclosure at all. Maybe you're about to do an experiment. So here's how you should look at it. The greatest minds are getting together to put together an experiment which will give them a simple and clear answer. They spend hours, days, weeks talking about how they should do the experiment. There's a lot of knowledge created before the experiment happens. Definitely you can extract it. They know everything. You can extract it, and often you can get valuable IP. For example, you can identify what are the 4 possible outcomes. Write pattern to cover all 4 outcomes, and then continue only with the ones that actually happen. And here's another important point. It is relatively unusual that an inventor tells you before they do an experiment. There could be, 2 reasons. One, the inventor has been educated properly. And the other one, somebody in the team felt that there's an IP event happening. So in the first case, you can just clap yourself on the back. But in the second case, it means you should really dig down into people and see what they can tell you. There's another example where you don't have a disclosure, and that's what Gil Perlberg calls request for invention. That's when the business tells R&D, we want you to invent something that glows in the dark and makes our logo look nice. Okay, so there's no disclosure, but we're going to be writing a patent. In conclusion, the inventor is hiding lots of details, maybe unintentionally, usually unintentionally. Even a complete disclosure is missing important details, especially the ones that relate to what the inventor doesn't believe in. It's not easy to get those details, but you need to do it before your competitors do. And I read, I think tangibly, I'm not sure, have a system which reads patents and identifies trade secrets hiding behind the patent. Well, forget trade secrets, details hiding behind the patent. You have all of these things you have to fight in order to do it. And I gave you methods, heuristics, metaphors, thinking tools. Please use them. And as my daughter used to say when she was very young, cup of juice. Just to give you an example, Mrs. Or Ange walks into your office, and she invented a juicer which simultaneously juices out the juice, the pulp, and the essence of the peel. And she shows you a CAD drawing of the device, just like we showed you with the scissors, and also a video showing how it works. So I think you now understand that this is the beginning of the disclosure and not the end of the disclosure. I'm now stopping the recording, and I'm happy to hear